Hello, my name is Dion and this video is on functions. Functions are mathematical machines. This machine is going to ask you for a number and it's going to give you back a number. And so let's say that I gave it 1 and it gives me 2. So this function it has the name f. It's a function. It's this machine. And the inputs are called independent variables and outputs are called dependent variables. And these are admittedly kind of weird names. So the way I like to think about it is that you are in control of the input, and so you are independent. On the other hand, the output is kind of decided by the machine. So the machine decides the output, and so the output is kind of dependent on the function. Those are weird names, but what you need to remember is that it's a machine. You put in a number and you get a number. Before I talk about how these machines actually work, I'd like to talk about what functions can do, what actually they can't do. So there's 3 things that's pretty important that they can't do. It can't give you 2 numbers. It will only give you 1 number. If I put in 1, it's not going to give me 2 and 4. It will only give me 2. And it also can't take in 2 numbers. Like at a time, I can only give in 1 number. There's no slot for me to insert, for example, 1 and 3 at the same time. Some machines are especially incapable and they will only take in some numbers. So say that this machine F will only take in 1, 2, 5, and 6. Then you can't insert something like 3 into the input. So the set of numbers that you can use as an input is called the domains. And so this group will be called the domain. And after you put in all the numbers in the domain, you will have a set of numbers that you can get as an output. Let's say I get 2, 3, minus 1, and 7. This is called the range. This group is called the range. And we're going to talk about those names again. So how do these functions actually really work? So functions have a description. It can look like this. It kind of looks like an equation. And we're going to look at the left side first. So f parentheses and then x. So what this tells you is that this is a name of the function. So okay, this is function f. What inside the variable, inside the parentheses, there's going to be one variable. This is the input, or what we said before is the independent variable. So before, I kind of talked about functions in terms of slots. X is the slot here. And so if we look at the right side of this, of this function, we see that there is a slot for the input. So let's say I wanted to, in this machine, and I'm going to draw a very badly drawn machine again. Okay, let's say I put in 1. What would be the output? What I do is, since this is a slot, I'm going to substitute x equals 1 into that equation. So what I write is f, I put in 1, and then 3 times 1 plus 1 is 4. This means that the output that this machine will give us is 4. And so that's how you calculate the output. You put it into the slot. And if you do that, we say that you evaluated the function f at x equals 1. So again, let's try another example. Let's say that I have this function gx. Gx is x squared plus 2x, and we're going to evaluate g at x equals 2. At x equals 2. In other words, I'm asking you, what is g of 2? Okay, so stop the video for a moment and think about that. Okay, let's evaluate it. So we have slots, we actually have, we have to put it in 2 times, but it's actually just one variable, one slot. So g of 2 would be 2 squared plus 2 times 2. So that's 4 plus 4. And so if you had a machine and the machine's name, I drew it even worse. And the machine's name is G, and you put in 2 into it, you would get 8. And that's how you define a function, and that's how you evaluate a function. Okay, so there are actually other ways to represent functions. And I'm going to introduce 2 of them, mappings and graphs. So these are a little like instruction manuals for these machines. So first, mappings. I'm going to draw 2 circles, and this is going to represent the function f. Oh, and the function f is what we've been talking about, the example I used before, 3x plus 1. And so on the left, I'm going to write everything I could put in. So let's say I'm going to put in 1, 2, 3, and 4. And I'm going to write every output I would get if I put these in. So I would get 4, 7, 10, and 13. And then what you have to do is you're going to draw an arrow that connects the input to the output. So if I put in 1, I get a 4. I don't get a 7, I get a 4. If I put in 2, I get, if I put in 2, I get 7. If I put in 3, I get 10. And if I evaluate f at x equals 4, I get 13. And this is what a mapping would look like. And notice, important here, this region I drew on the left, this circle, this group, it's what I said was the domain before. It's the group of inputs. And on the right, we have our group of outputs. And before I said that this was the range. And so it's really easy to see what the domain and range of a function is if you have a mapping, if you're looking at a mapping. And next, we're going to look at graphs. So you kind of already know how to graph equations, and you can do the same thing for functions. So for every input-output pair we have, so from this mapping, let's say we have 1, 4, 2, 7, 3, 10, and 4, 13. So for every coordinate pair we have, we're going to draw that on the coordinate plane. Okay, so we're going to represent it with 1 dot. So let's say this is 1. Oh, sorry, mistake. So on the x-axis, we're going to put in the input. On the y-axis, I'll write the output. And so this 1 dot represents this input-output pair. And let's say that this is 2, and that this is 7. And I would draw a dot here. For 3, I would get 10. And so maybe the dot is about here. 1 more dot. 4. Okay, I need more space, but it would be around here. And so these 4 dots essentially are saying the same thing that this mapping is saying, and it represents this function. Now, this kind of looks different from what we did when we were graphing equations. But what the difference is that this one has only 4 numbers in its domain. So if I made the graph for all real numbers, this is what it will look like. So this is a nice graphing calculator that I like to use. And so 1, if I put in 1, I would get, I think 1 is here. If I put in 1, that's 4. And around that, 1, 4 is around there. And so this red line is the graph of the function f(x) if I drew it for all numbers.